so small yet, too.
Okay, topic 1 was restrictions. So when we think about restrictions on rationals, what are we focusing on that we're worried about? Do you remember what the big idea was? We don't want to ever do what with fractions? We don't want to divide by 0, right? That's the big idea. Okay, so what is it that I do not ever want x to be on the first one? I don't want a -7, right? Because then that makes that bottom 0. Number 2, I don't want x to be a 0, because then it would make the bottom 0. Okay, on the third one, I don't know yet. I have to factor first. Okay, so it's a complex. I'm going to try to see if I can do this with some trial and error here. 2x times x. Here, I have to either go with a 2, 2 or a 1, 4. Can anybody see an option using a 2 and 2 that would work? Nope. An option with a 1 and 4 that could produce a 7. Do you see one?
2x subtract 1x plus 4.
The 1 and the 4 to make 1 and 8. So that makes a plus 8 and that makes a minus 1. So that is good. It made a 7. So now I don't want x to be, this will be a fraction. Remember those? Those are fraction answers. +1 over 2 and -4. Okay, multiplying, dividing, reducing, all of the above. Okay, so x minus 1 stays. Okay, I'm going to factor this with a simple trinomial strategy. Can you think of multiplies to 5? Adds to negative or +4? Multiplies to 5, so 5 times 1. Okay, next I'm going to factor. This is a difference of squares. So 2 brackets, x plus 5, x minus 5. And the last is also a factor in this style. Is a, I can see a GCF style. Okay, so you're going to have to start getting really fast at recognizing that's that style, that's that style. So I can take an x out. What do I have left after the x? Okay, so that's all from last unit, the factoring stuff. And now we're going to look for anything that would cancel. So any sets of factors that would cancel. So x minus 5 and x minus 1. And there's an x plus 5. How do I write my final answer? There's an x that's remaining there. That's all that's remaining, but how do I answer it? (1 over). because the x is on the bottom, so I can't just write x. That's different. Or you can think about on the top, everything canceled, so 1. Okay, number 2. Complex. Okay, you can always do this a long way, but on these I'm trying to challenge you with ones that are like 2 options. So here's what I'm going to give you. There's a 1 and a 1 at the end. That's the only thing you can do to get 1. Now, here's 2 options. Is it going to be 2x, 2x, or 1x, 4x? Those are your 2 options. That's what you're just trial and erroring. 2x and 2x. That's how you're going to get your 4x. Sometimes on these you can look other places for hints as well, maybe. I'm not sure if sometimes that works. Okay, bottom, can you simple trinomial to get a 12 and a 1 in the middle? Can you multiply to 12? So 4 and 3 to get the plus 1. Okay, what do I do with this whole process? There's a dividing a fraction. So we will times, and we're going to flip. Okay, 2x plus 1, there's nothing. So I'm going to write it on the bottom. But this, there's something I need to do with it. Do you remember that style? Negative out. We don't like our negative variables. So negative 1 out. Now, what kind of variable do I have? Positive x. What kind of number? Minus 3. Okay, you got to switch everything with signs. Okay, that's all done. Now it's time to cross out anything on a top, bottom. So x minus 3 and a 2x plus 1. You can only cancel one of them though, right? You can't all of a sudden cancel the double. Okay, last, I'm going to reduce the numbers. What do you want to divide by? I think I'm going to pick a negative 4. You can do 4, but I think I'm going to pick a negative 4. So I'm going to cross this off and put negative 4. And I'm going to cross that off and put a 1. Okay, now let's look at the x's. We can divide each by an x. So this would, x would be gone, and the x6 will turn into a x5. X to the 5th. Now I'm going to take a y out of each. So the y on the top would be gone. And take a y out of the bottom. So y7 turns into a y to the 6th. Okay, so I'm left with Okay, adding and subtracting. So we're gonna have to do a lot of work with denominators when we add and subtract. So let's get some factors. Can you do that on both of them? Okay, we good with the factors? Everyone matching? Okay, ready to pick. What do I all need? I need an x plus 5. I need an x minus 3. That fits. And I need an x plus 6. Now that fits as well. Okay, common denominator. Good. Now, what did I do to the first fraction? What did I do to the bottom? So I had that. So therefore, it got multiplied by x plus 6. I'm going to look at the second fraction. It had that and that. So what did I do to it? Multiplied by x plus 5. Okay, now I'm going to multiply like that. So 6x squared multiply plus 36x Okay, do you remember on this second part, this is where I get a lot of mistakes on a test, because I have to remember I'm putting a -8 through that. Okay, that's where I get a lot of mistakes on that negative sign messing it up. So it's going to be minus 8x minus 40. Okay? And it's usually forgetting to do it on the second one where the mistakes seem to happen. Okay, I'm going to finalize it here. I can put that together, which is what, 28? You always still have to write it with your denominator. You can't just forget about your denominator. It still has to keep coming. Okay, can you factor? So on this one, can you start GCF and trinomial? You got to factor it twice. Can you try to do it on your own? Do a GCF and then a trinomial. You'll have to do it twice. Okay, on the other one, can we do a difference of squares? Okay, we're gonna go to our common denominator now. What do I all have to put into this denominator? So I'm gonna need an m. I'm gonna need an m minus 2. I'm gonna need an m minus 1. And I'm also gonna need an m plus 2. Yes, it fits. Yes, it fits. As in, like, I can put my finger on the 3 of them and 3 of them. Yep, yep. So that's the common denominator. All right, so what's missing? Looking at the first fraction, it had those three. So the missing thing was the m plus 2. Okay, second fraction, it had that and that. So it was missing the m and the m plus 1. They were both missing. Or not m plus 1, m minus 1, right? Okay. Ready to time. So the first multipliers will be 4m plus 8. Okay, this is a scenario where I have 3 things multiplied together. So we're going to multiply 2 of them, and it doesn't matter. Which 2 do you want to pick? I think I'm going to pick these 2. And then after, I'm going to do it by a 7. Okay, and you could have picked 7m first and then that. It doesn't matter, you just have to pick 2 of them. So this will make m squared minus m. Okay, now I'm going to multiply it by 7. So plus 7m squared minus 7m. Okay, are we okay to follow that? I did those 2, finished, then I did by 7, yeah. Okay, finalizing, I think I have just one more thing really to go, is putting those together. So 7m squared minus 3m plus 8. Okay, complex. Okay, on this I'm going to write over 1, just so that matching everything up is a little bit easier. Okay, so this bottom of 5 and this bottom of 1, I'm going to need to have a 5. I need a denominator of 5. So the x, I'm going to do nothing with it because it was a 5 on the bottom. And this 1, I'm going to times that by 5. That's how I turned the 1 into a 5. So now this is going to become a 10. Okay, now this had a 20 and this has a 1. So I'm going to need to have a 20. This was a 20, so this stays. This 1 turned into a 20, so I'm going to have to multiply it by 20. And then that would make minus 100. Okay, now I'm going to turn that whole statement into a flip multiply. So x plus 10 over 5 times and flip. Okay, instead of dividing that fraction, I just times and flipped it. Okay, right now I'm looking at the 20 and the 5. What could I do to that? Divide by 5. So if I divide by 5, that's a 4 and a 1. Then, can I factor this? Difference of squares. So x plus 10. All right, so on the top, I have a 4. That's a 1, that's a cancel. So that's my final answer. Okay? Please do not try to cancel like the 10 and the 100 because those are adders. You can't cancel them unless it's something times something. Okay, we have 2 equations to solve here. I gave you 2 strategies. And which one is this? Cross multiply or common denominator style? This would be I can cross multiply that style. The reason is because I only have 1 fraction on each side, and then you can do that. Okay, so that times equals that times. Can you work on your distribution here? On both sides, you're going to have to do some distribution. Okay, here's the algebra. What do you do as soon as you see x squareds and x's? What do you need as soon as you see x squareds and x's? You need a equal 0. We have to have an equal 0. So let's do that. What's the boss of this whole thing? The 6x squared is the boss. So I'm going to think about everything with that put. So I'm going to minus x squared and minus 11x. Okay, I'm zeroing that side because the 6x squared was the boss and I wanted to stay. Okay, so 5x squared minus 20x. Okay, once we're at the 0 part, can I factor? Do I have a factoring strategy here? Yep. GCF styled. I can take a 5x out. X minus 4. So x equals 0, x equals 4. Okay, I would like to circle it to say it's my answer, but I can't do that yet. I can't commit. I gotta double check. Is x allowed to be that? What am I worried about x being? I'm not allowed to be a 3/2. I'm not allowed to be a negative 11. So this means we're good. Those are good answers. They would work. Or they're allowed. Okay, the bottom question. So on this one, the cross multiply strategy is not gonna work. I'm gonna write the 2 as a 2/1, and I'm gonna start looking at the bottoms. Okay, the second fraction, we can do what with that factoring? GCF. Okay, so now it's my time to pick a denominator that will work for everything. I need a x and an x plus 1. Okay, first fraction, it had a 1 on the bottom. So what did I do to it? I did, well, everything there would have had to have been. Second fraction, I did nothing to the bottom. And the third fraction, the bottom would have got multiplied by an x. Okay, so there's the missing. Okay, here I have 3 things, so I'm going to pick 2 of them. So I'm going to go with those 2. So that is x squared plus 1x. Now I still have to multiply it by 2. Okay, so I get a 2x squared plus 2x. This fraction, we didn't do anything, so minus 1. And this is 3x. Okay, this is the point where if the bottoms are the same, we're concluding the tops have to be the same. Okay, so once you see all of this stuff, what's your first instinct with equations? We need a 0. We need an equal 0. So I'm going to minus 3x. Okay, so 2x squared minus 1x minus 1. Factoring 2x times x. That's the only way I can do that. And a 1 times a 1. That's the only ways you can do those. So now it's all about signs, so plus and minus signs. So I need a negative. So minus 2. And there's my minus 2x and a plus 1x. So x equals, that's a fraction. Can you think about how to write that as a fraction answer? Negative 1/2. And x equals 1. Do I have to omit any answers? Do I have to cross any off? What is x not allowed to be? 0 or negative 1. Can't have that. So that's good. It doesn't match that. Okay, 4 word problems. So the first one is one of the chemical questions. So we already start with a solution. A 10-liter solution is already 30% strong. So I'm going to times it by 0.3, which means there's already 3 liters of chemical in it. So this is how I'm already starting off. Then I'm going to add. I'm going to add antifreeze, I don't know, so I'm going to call it an A. Okay, now the chemical. So I started with 3 chemical, and then I'm adding more, so more antifreeze. So I had already had 3, and I'm adding more, don't know. Total fluid. At the start, I had 10 liters, but as I poured antifreeze in, the 10 liters also rose up in the jug, right? The fluid went up. The goal is to end up at 50%. So I always just write it over 100. If you want your math to be a little easier, you can just say a half. I'm just going to go through with this just so you can have the consistent format. Okay, so now I'm picking my strategy. This type I can cross multiply. Okay, make sure when you multiply that you do a double multiply, a distribution multiply. Okay, I'm going to collect A's. So I'm going to minus 50A. I'm going to minus 300. Just Just working with my isolation strategies here. Divide by 50. So A equals 4 liters to add. That's what you're going to add. Okay, make sure on these word problems your answers kind of make sense. Like a negative answer wouldn't be very good. Probably something crazy like 30, 80 liters. That might seem a little bit off. Okay, we have John and Jacob working. Oh, I shouldn't have used 2 J names, but John and Jacob, they're both working. So time and rate. It takes John 45 minutes to push mow the yard. Is that a time or is that a rate? John, rate. If Jacob helps, it takes them 25 minutes. So that is a time. If Jacob were working alone, how long would it take Jacob? Okay, so we do time over rate. So that's John's job completed plus time over rate, Jacob's job completed, and their jobs will make the whole job. Okay, cross multiplying is not going to work. So we're going to common denominator it. So I need a 45x. Okay, I'm just going to already do the right hand here because 45x over 45x. All right, first fraction. I would have to do the bottom by an x, so I will also multiply the top. Second fraction, I would multiply by 45. So multiply that by 45. Okay, now we would get to a point where the bottoms are the same. Conclusion, the tops are the same. And this is an isolation algebra technique. So try to collect x's together. Okay, so do you notice how in my answers I'm writing a nice conclusion? That's the minutes it takes Jacob if Jacob is working all alone. Jacob's rate. Okay, we have 3 hoses that are going to fill up a pool. So number 1, number 2, and number 3, using their times and their rates. Okay, reading it. If you were to only use the first hose, it would take 20 hours. So that's an alone finished job, so that's a rate. If you were only using the second, it would take 15 hours. That's a rate. Hose 3 takes 25 hours alone. That's a rate. How long does it take if you were to use all 3 of them? So what is that time? Okay, so now time over rate is the job that they do, plus the second job, plus the third's job. They make up the whole job when they're done. Okay, common denominator, I have to find something that will work. Divisible by all of that. What do we got? A 600 maybe? 300 is lower. On this one, it's one of them that is okay to pick bigger. It's not going to mess you up with your algebra. On a lot of the other ones, if you pick bigger than you need to, you're going to make too complicated algebra. Okay, so 20, turning it into a 30, I would have to times by 15. Turning the 15 into the 300, I would have to times by 20. And 300 divided by 25 means I timesed it by a 12. And then we know how to write 1. Just whatever you have, make it the same over the same, right? Okay, this is the good part. We can say the bottoms are the same. We're done with that. So 47x, that's all 47 put together, equals 300. So if all 3 hoses are going to be going at the same time, it's only going to take 6.38 hours to fill it up. Okay, a boat travels upstream in the same time it goes downstream. So the time up equals the time it goes down. Okay, I'm just going to go on the side here with my formulas because I always know the velocity in my car is in kilometers per hour. So kilometers per hour. Distance is kilometers per hour time. Now this formula wants me to use time, so I'm going to switch. Time equals distance over velocity. Okay, now we're going to fill in what we know. It travels 18 miles upstream, 20 miles down the stream, okay, if you're going up the stream, would you add or subtract? Subtract, and when you go downstream, you would add. And what do I want to know? You're either going to be given one or the other, so be careful. I might give you the water speed and you get the boat, or I might give you the boat speed and you get the water speed. One or the other. So here's where you would look to fill in. The current of the water. So I would like to know the boat. So boat minus the water, the boat plus the water. So here's where I would get mistakes. If I asked you to find the water, please make sure that this subtraction is in the correct order. You don't want to do the water minus the boat. That's not going to make sense. It's always the boat minus the water. It's always in that order, okay? If you did it wrong, you're going to realize it because your answer at the end will be a negative boat speed or water speed. Something would be negative, and that's not correct. Okay, I'm picking the cross multiply strategy. So I get an 18b plus 36. 18b plus 36 equal to 20b minus 40. Okay, algebra, I'm going to put the b's together. The 20b is going to be the boss here. It's bigger, so minus 18b. I'm going to add 40. And divide by 2. So 38, what are we, miles per hour is the boat speed. Does my answer seem reasonable or make sense? Yeah.